Thank you, Beryl, and thank you everyone for attending today. We're going to be talking about Local Run Manager, the research use only version, version 2, and this is an introductory webinar. Topics we are going to cover today are an overview of Local Run Manager, sometimes shortened just to LRM, particularly what the software functions are and the instrument it supports both on instrument and off instrument. We'll discuss the available versions, the features of Local Run Manager 2, how you access and use the software, how you set up runs and analyze data, how that interacts with the instrument control software, and then how you view your analysis results, as well as how you use some important system settings. So let's start out with an overview. The Local Run Manager provides an integrated software solution for such tasks as user management, run creation, data analysis, and viewing your results. This is Windows-based software. It is compatible with both Windows 7 and Windows 10, and it is designed to analyze data from our benchtop sequencers. That includes the MiniSeq, the MiSeq, the NextSeq, and the iSeq. This is not designed for and cannot be used to analyze data from our high throughput lines, including the HiSeq 2500, HiSeq 3000, 4000 RX, or NovaSeq. Local Run Manager is a unified framework with modular architecture. The base part of it, the framework, provides common analysis engines and dashboards and monitoring. It's also where you take care of such tasks as user management and run creation and analysis creation. On top of the framework, you can install specific analysis modules. Each one of those modules has its own run setup, its own analysis pipeline, and its own supporting. And we will talk about what the benefit of those modules is in just a moment. After your run is set up, you will then communicate that through the instrument control software through Local Run Manager to configure your run. The run data are collected as the primary analysis from RTA, and those base call files are then transferred back to Local Run Manager in order to perform further analysis such as BCL to FASTQ conversion or other analysis pipelines. The benefit of this architecture is it allows for updates to specific components without needing to update and revalidate the entire software suite. So if you're familiar with something like MiSeq Reporter, you may be aware that if we wanted to add a new analysis pipeline, we had to update the entire software suite. Or if there was a bug fix, we had to revalidate and upload an entire new software version. With Local Run Manager, that's not the case. So if we just need to update one module, everything else stays the same and does not need to be revalidated. Speaking of MiSeq Reporter, on the MiSeq, Local Run Manager 2 is replacing MiSeq Reporter. Currently, MiSeq Reporter is still supported and is also still available off instrument. LRM2 is bundled with MiSeq Control Software version 3, and that update is an optional upgrade. Instruments are still shipping with MCS2 and MSR 2.6, and you can update them to MCS3 if you would like. It's also downgradable back to version 2 if you prefer. There are several different versions of Local Run Manager currently available, and we're going to give an overview of each one of those. There is the MiniSeq, which is RUO version 1.3. The MiSeq, iSeq, and NextSeq each have versions of version 2. And then there are specific DX versions for MiSeq DX and NextSeq DX. We also have an off-instrument version, version 2.0, and this can be used to analyze data from our benchtop sequencers on a separate PC. So again, that's the MiniSeq, MiSeq RUO data, NextSeq RUO data, and the iSeq. If you have a MiSeq that is running MCS version 2, note that the AmpliSeq workflows, DNA Amplicon and RNA Amplicon, are not available through MiSeq Reporter. So if you need to analyze that data locally, you would have to install the off-instrument version. These can also be used to compare results from MiSeq Reporter and Local Run Manager for validation, in case you're interested in upgrading and want to make sure that your results are the same. Let's go through these a little bit more detail, just because if you were to go to the Illumina website and search for Local Run Manager, you may find a few different versions. The MiniSeq version was the first one released a few years ago. This is currently on version 1.3 and is available on instrument for the MiniSeq with these list of analysis modules available. There is a specific off-instrument version of version 1.3 that is designed for the RNA fusion module only. This is a fairly old version, and we'll talk about version 2 in a moment, but for most purposes, if you're installing an off-instrument version, it's going to be version 2. There are two DX versions for either the MiSeq DX or the NextSeq DX installed on the DX drive while the instrument is running in DX mode. This only supports the DX modules, so there's a germline variant and somatic variant module available for both. Then the MiSeq DX can also run the cystic fibrosis modules and the extended RAS panel. There is no off-instrument version for the DX LRM. Version 2 is the current off-instrument version and is also available on instrument for the MiSeq, the iSeq, and the NextSeq. As mentioned, the MiSeqs do not ship with this, but they can be upgraded to it. iSeqs do ship with Local Run Manager installed, and new NextSeqs that are running NCS version 4 ship with Local Run Manager. Older instruments that are running NCS 2 are being upgraded in the field, and if you would like to schedule an upgrade to your NextSeq, please contact your field team so they can schedule that. Version 2 has a longer list of modules available and updated versions of the modules compared to version 1. Most of them can run on the instrument. The two here that we have a note for are TrueSight Tumor 15 version 2, and RNA fusion cannot run on board the iSeq, mainly because the iSeq has a little less processing power and RAM available on the onboard PC. However, if you run those panels on the iSeq, you would then be able to use the off-instrument version of Local Run Manager. Some important notes down here at the bottom. These separate frameworks are essentially separate software, and the modules are not intercompatible. So if you try to install version 1 modules in the version 2 framework, they won't work, and vice versa. So you can uninstall the version 2 modules on the MiniSeq version 1 framework. The DX versions are also not intercompatible with the RUO versions, so you cannot install the DX modules in the RUO versions, either 1 or 2. And you can also not install the RUO modules into the DX framework. You also cannot install the version 2 framework on a PC that has version 1.3 already installed. So if you do happen to have that older version of 1.3 off instrument that's for RNA fusion only, and you wanted to install version 2, you would need to uninstall the 1.3 framework first before you install the version 2 framework. So those are just some important notes to keep in mind. Focusing now on version 2, this is designed for parity with MiSeq Reporter workflows. So anything that you are able to analyze with MSR, you should find an equivalent module in Local Run Manager that can perform the same analysis. As mentioned, this is a modular workflow installation. Only install and update the analysis modules you want to use. So if all you ever do is generate FASTQs, only install the Generate FASTQ module. If you're interested in metagenomics, you can install that module, but you don't need to install the RNA amplicon module, for example. Features of Local Run Manager that we'll go through includes a one-step process for setting up workflows. So you no longer need to generate sample sheets with a separate program like Illumina Experiment Manager. You can instead set your runs up directly in Local Run Manager or create sample sheets in Local Run Manager, and then configure your run or your analysis from there. There is a sample sheet import option, so you can import sample sheets that you already have, although we'll discuss a couple caveats with that later. There is support for custom kits or free entering of custom setups. This free entering of custom setups also allows you to enter ends into your index sequences to use as wildcards to stand for any base. There are optional user management selections, which we'll discuss, as well as audit trails, which are useful for operating in a more regulated environment. So in terms of accessing Local Run Manager, this is again similar in concept to MiSeq Reporter. You view the interface through a web browser. If you are on the instrument or on the local PC, you just put in localhost into the web browser. This uses the standard HTTP port of 80, so you don't need to put in a separate port number like you would for MSR. While you're using a web browser, the address is localhost, which just means this instrument or this PC. So an active internet connection is not required as you are not communicating off of the PC. Now, if you have your PC or your instrument connected to a local network and you're on the same domain, you can also just put in the IP address of that computer or that instrument, and you'll be able to connect to Local Run Manager on a separate computer without needing to install Local Run Manager on that computer itself. The interface is optimized for Chrome or Chromium. It also works well in Firefox, but the displays do not render properly in Internet Explorer, so keep that in mind. Depending on the version you have installed, the UI elements may look slightly different, but they function all the same for version 2, and we'll go through what some of those elements are. You can see the system and version that you have installed at the top and bottom of the interface. Here we are seeing installs on a MySeq and an iSeq. If you have this installed off instrument, it will instead stay off instrument and then give the computer name. And you can see the exact version you have installed at the bottom of the screen. There's a status bar that shows things like the number of runs that have been performed or are currently in progress. You create your runs through the Create Run button. Then you can see your list along with their status down here in the center of the screen. There's also a Run Actions button that allows you to do things like edit your run or requeue analysis, and we'll go through some of those options in a moment. Before we get into run creation, I want to spend a moment talking about user management, as this affects everything you do with Local Run Manager. This is optionally enabled in version 2 RUO. In the older version 1.3 and in the DX versions, you do not have this option. So user management is always enabled in those, which means you need to log in and have admin credentials for installations. So if you have this turned on, you can create new users and so give different users different logins, which are then tracked in the audit trails. You can decide if they're either admin or regular users, and then send temporary passwords for them that they would change once they log in. You can also edit current users, delete them, reset their password if they forget, unlock passwords, change their permissions, and so on. When you first interface with Local Run Manager 2, that user management is turned off. If you want to change that, that's a settings selection. Then you just toggle it to on. Now, if it's turned off, which is the default, you will automatically log in with the admin account when you connect to Local Run Manager through the web interface. This also applies to module installation. If you have user management turned off, any user can install a module, and the admin login is not required. If you have it turned on, then you would need to include the admin credentials when installing the modules. This also affects setting up your runs through the control software. If you have user management turned on, then you will need to provide a user login through the control software in order to access the information in Local Run Manager 2. If you have this turned off, when you open up Local Run Manager mode, which we'll show in a little while, you will automatically be able to see any available runs. So just something important to keep in mind that may be important for your particular usage environment. And now that we've accessed Local Run Manager, we're going to go through how we set up a run. The general workflow is to log into or connect to Local Run Manager 2 through the web browser, select the Create Run, enter in your run details and settings, add your sample information, and then save your run. When you click on this Create Run button, you'll see only the modules you have installed. If this is your first time using Local Run Manager, you may not have any modules installed, and you'll actually see a big orange banner at the top of the screen warning you of that fact, and then redirecting you to our support site to download any modules that you may need. Once you have a module installed, you'll see it show up in the Create Run list, and then you'll select that module type and continue with setting up your run. So once you have the run creation screen, you'll see a few options. You can use this Import Sample Sheet button to automatically populate your run and sample information with the pre-created sample sheet. A couple notes here, sample sheets can be created in Local Run Manager 2. You see an export sample sheet at the bottom of the screen, and we'll go over that as well, or using Illumina Experiment Manager if you already have workflows set up for doing so. An important note about using IEM is that no matter what instrument you're using this on, or no matter what instrument type you're using this to analyze data, you always need to select the MySeq as the instrument type. Local Run Manager 2 will automatically reverse complement the second index for data coming from the NextSeq, MiniSeq, and iSeq. IAM will also do that when generating the sample sheet. So if you select one of those instrument types, you'll run into a situation where the index 2 will be reverse complemented twice by each software, returning it back to the forward orientation and resulting in a demultiplexing failure. And this is something we're going to touch on again in a couple more places and go over greater detail later. I just want you to keep that in your mind if you're considering using IAM or used to using IAM. Let's take a look at what happens when we start a run with importing a sample sheet. So we'll create run, select generate FASTQ. Here we're just going to import a sample sheet for a run that we've already created. You can see here our run name is populated as well as our read length, sample information, and index information. If everything is correct, we then click on Save Run, and we'll return to the dashboard where we can either set up the run in the control software or import data for off-instrument analysis, which we will show in just a little bit. Besides importing a sample sheet, you also have the option to manually set up your run information. Anything that has an asterisk is required for run setup, such as the run name. You'll have a drop-down list that will determine which indexes are available that's based on the library kit type. There is also a custom option, which we'll discuss in a moment. But here's an example of setting up a run manually. We're going to create the run, fill in our necessary run information. Here we're going to select from our installed kits, choosing Nextera. We have the option to toggle off and on adapter trimming or change our read lengths. Here we're going to add a couple of samples. So you can just start typing or copy and paste from another sheet. If there's an error, that'll flag it right away. Here we see that there's a space in the sample ID, which is an invalid character. So we just need to fix that. Once we fix that, we no longer have the validation error. We're then going to select our indexes and add in our second sample. Again, just choosing from the available drop-downs. Once everything is ready, we see the Save Run option is available, or Export Sample Sheet. Now, if you make an error, such as repeating your index sequences, that will automatically be flagged as well. And you will need to fix this before you're able to proceed with saving the run. We mentioned also custom entries. One of the drop-downs available in the library prep kit selection is custom. If you select custom, there's no longer a drop-down option in your indexes. Instead, you can put in your index sequences as a free text entry field. This allows only for AT-GCNN, so standard bases. And here N are used as a wildcard, similar to MySeq Reporter, to stand for any base. And note that this is different from BCL to FASTQ, or base space, which runs BCL to FASTQ, where Ns are considered literal N calls. So an important thing to keep in mind is you can do things like N padding when using Local Run Manager, but if you're uploading your run to base space, it will not be processed the same way there. Also, index lengths must be consistent between samples. So if you have a mixture of a different index lengths, such as 6 or 8, you can NPAD here to make them all the same length. But if you leave them as different lengths, that will cause a validation error. And as noted before, even here in the custom setup, when you're putting in your index 2 sequence, it should always be in the forward orientation, no matter what instrument you're using, or no matter what data type your instrument are coming from. Local Run Manager will generate a final sample sheet that will automatically reverse complement that index 2, depending on the instrument type. So always enter in the forward orientation. Besides custom option, you have the ability to install custom library prep kits. And to do that, you go through the Tools drop-down menu in the Local Run Manager interface, select Library Prep Kits. This will take you to your library prep kits list, and you have the option to either download a template or download an existing template from an existing kit. The first option is useful if you just need a blank template, if you're putting in something completely unrelated to any kits that we currently have installed. Let's say you have a TruSeq Lite kit or an Xterra Lite kit and you just want to make some changes or add some extra indexes. You can download the template for that specific file. Once you make the changes that you need or make the different additions that you need, you can then use the Add Library Prep Kit button and upload that file, and then it will display within the kit selection. Note that there is a maximum of 100 custom library prep kits per module. When you set up a kit, you tie it to specific modules. If you happen to run out, or if there's old ones you just want to get rid of because, say, your drop-down menu is getting cluttered, you can delete them from this menu and remove them from that drop-down list. So previously we were showing setups in just the Generate FastQ module. Different modules will have more advanced analysis settings that are more than just adapter trimming. So these can also be selected automatically when importing a sample sheet, or you can select them manually when setting up the run. These are things like selecting your aligner and your variant color. If you're running a targeted assay, you can also import your manifest, and you can do that here while setting up the samples. Or if you have frequently used manifests that you're always going to be running with your assay, you can install them into the specific module using the Add Manifest button. In that case, the manifest will just be available as a drop-down in your run setup. Different modules have different analysis options, so please see the module guide for your particular analysis for the full available settings. Let's just take a look at what that looks like when we're looking at a more advanced situation. In this case, we're selecting DNA amplicon. We're going to import a sample sheet for a DNA amplicon run. And we'll see things like the read lengths, the variant collars, and so on are already pre-filled in based on our sample sheet selection. We still need to include the manifest. If we install it into the module, we can just select it from the list. But here we're just importing the manifest. It's then a valid run as the manifest is available. We save the run and we're able to continue. Just a quick note about that. When your run is valid, you have the option to export your sample sheet. So this is useful if you're, say, using this off instrument and just setting up a sample sheet that you're going to then import onto an instrument later. You can also save your run, which will then return you to the dashboard. Once you return to the dashboard, you'll see your run with this Ready for Sequencing option, and it says the same thing even if this is not actually on an instrument. You'll see this Actions menu. This gives you a few options. Edit allows you to change the run or sample settings, so change the run names, change the sample IDs, change the index assignments. Hide just removes the run from your dashboard. Import then allows you to import existing sequencing data. This is useful for analyzing off-instrument, but it's also useful for on-instrument if you need to change the analysis workflow. So you initially set up your run as Generate FastQ, but then later you decide you want to run it through a different module. Speaking of off-instrument though, let's talk about that for a little bit first. If you want to install Local Run Manager off-instrument, just go to our support site and you can download the installers from there. As mentioned, there are a couple different off-instrument versions, so you want to make sure that you install version 2 installer. This will install the framework for Local Run Manager. Installing the framework for Local Run Manager does require full administrative access on your PC, along with the ability to install and run services. In many regulated environments, a regular user does not have these permissions. So please consult the software guide first to check the requirements and discuss with your IT department to make sure that you are able to install this software, or they may need to do it for you. Once the framework is installed, you'll still need to install analysis modules. The framework itself does not come bundled with any modules, which allows you to perform the modular installation of the workflows of your choice. If you need to install any reference genomes for alignment, you can go to our iGenomes repository for some ready-to-use sequences and annotations, or you can also just download a reference sequence from any public repository to use. If you're installing this on a MySeq, You can use most of the MySeq reporter genomes that are already installed, but if you're running the human genome, we recommend that you update to our more recent version of HG19, which has updated annotations that are more compatible with the LRM workflows compared to the MySeq reporter workflows. After everything is installed, you can then import your run data for analysis. So here's an example run that we've set up. You can see it's ready for sequencing. And here we've already clicked on that import button. Once you do that, you'll need to manually provide the run folder path that you want to import. There's not a browse option to go to the particular run folder that you want. The easiest way to get that is just through the Windows Explorer to open up the folder that you want to import, copy that path, and then paste it here into the import path. Once you do that, the menu will change slightly and ask you to specify your base output folder. This is where your run data will be output to. You'll see a value that's automatically filled in from the run parameters file from your particular run, but note that this may be a path that's not accessible to you from your current location. So it may be another drive from your instrument, it may be a network location, so you may need to change the folder here to be something local to your particular PC. That path can be changed, it just needs to be a valid path. That can include a local folder on your computer or a network location that you want to output your data to. Note for this software and most of our software, you want to use the full UNC path for your output. So it's going to look something like // server name, folder, etc., and not a Windows mount point like the Z drive. That can cause analysis failures and is not recommended. Once you import the run data, you'll see analysis starts automatically. So we've seen how to set up a run, how to use the off-instrument version to import your data. But let's take a look at how this actually works on the instrument. So 3 instruments have an onboard version of Local Run Manager, MySeq, iSeq, and NextSeq that are running NCS version 4. These each have slightly different modes, so I want to talk about what's common and what's different, and then we'll see some examples. All 3 instruments have a Local Run Manager mode. In this mode, you create the run in Local Run Manager, as we showed, and then select it through the control software, and I'll show you what that looks like on each instrument. All of these instruments in Local Run Manager mode also have a base space upload option. What this means is you set up your run in Local Run Manager, select it in the control software, and then also select to upload to base space. What this also means is that for NextSeq, you no longer use Prep Tab to set up your runs in base space. You instead set up your runs in Local Run Manager, again, either manually or importing a sample sheet. Select the base space upload option, and then automatically upload your data to base space without having to set up the run in Prep Tab first. The MySeq has 2 other modes. There's a sample sheet mode, which just imports a sample sheet similar to MCS version 2, and also allows for base space upload. The MySeq has a manual mode that only outputs raw data. You do not include a sample sheet, so there is no analysis that takes place in this mode. And with this mode, you can set up the instrument for base space run monitoring only, but because there is no sample sheet, there is also no option to upload your full data. Sample sheet mode and Local Run Manager mode on the MySeq allow for base space data uploads, manual mode does not. This is slightly different on the iSeq and NextSeq. Those instruments also have a manual mode, but it's different than the MySeq version. Instead, this outputs raw data only. However, you can attach a sample sheet. This particular sample sheet, unlike the MySeq sample sheet mode, is not validated by Local Run Manager. Instead, that sample sheet is copied directly to your output location or uploaded to base space. This also allows for full data upload to base space or run monitoring only if you prefer. And the differences between these modes, this manual mode and the sample sheet mode on the MySeq, does have some implications for how you set up your sample sheet, so we'll go over that after we discuss the different instrument modes. Let's start with the MySeq. So this is MCS version 3. If you're used to version 2, you'll see this looks pretty similar. You just have the sequence button to start with. But now when you open that up, you'll see 3 different modes: Local Run Manager mode, sample sheet mode, and manual mode. We're not going to go through manual mode on this one. It's just inputting your read links and then any options like custom primers, and then putting in an output location. So fairly straightforward. Let's take a look at local run manager mode. Here we're going to select that mode. We have the option to use BaseSpace after we select the mode we're running in. You would put in your account to log in. If you have a BaseSpace on site, you can use that option as well. For this example, we're not using BaseSpace, so we're just continuing. We're going to select the run. You can either tap on the touch screen to select the run you want, or use the up and down buttons to select your run. You can also preview the different samples, make sure everything is correct, and this is the correct run that you want to select. If it is, you can click on Next. You're then going to go through loading the flow cell, loading your reagents, your PR2 and waste, loading your reagent cartridge. After that, you can review your run, and this is important to review as once you start the run, you cannot change your run configuration. So if you notice here that it's incorrect, you can change between read types or change any of your read links. But if everything is correct, just go ahead and click Next. After that, you'll go through the pre-run check and be able to start the run. If you use sample sheet mode, this is most similar to the current MCS2 version where you load up a sample sheet. So here we're going to select sample sheet mode. Again, we have our BaseSpace options, which we're going to be skipping for the purposes of this demo. Notice that you do have the option to not use Local Run Manager for secondary analysis. So if you're only uploading to BaseSpace and you don't want local files, you can check that option. Here we're going to select our sample sheet. Now notice this takes a few moments to validate your sample sheet, and this will come up with a list of errors. In this case, we have repeated index IDs, which would cause an analysis failure. So this sample sheet validation will warn us of that. You then can either make changes to your sample sheet and reload it. In this case, we're just selecting a valid sample sheet. Then once everything is correct, we can review that this is the right sample sheet and the right run setup. Select Next and continue with our loading. Now, one thing you may run into, just as a note, is if you have older sample sheets that you're used to using with MCS2, the validation with MCS3 is much stricter. So sample sheets that may have passed the previous validation may not pass this validation. And that has to do with things like making sure all your analysis settings are correct, making sure there are no extra lines or extra spaces. We do recommend, if you're going to use IEM for sample sheet mode, update to the latest version of IEM. If you do run into problems, you can always import your sample sheet into LRM and set up your run through that mode and fix any errors that it flags. Let's take a look at how this works on the iSeq. Just as a note, when you select sequence, we'll show you here, you just have your local run manager option. If you want to change to manual mode, or if you want to enter in your BaseSpace credentials, that is done in a separate system setting mode here with these 3 lines, or in the hamburger menu, as it is often known, where you can enter your credentials or change your mode there. Once you're ready, we'll just select sequence to continue. Here we select sequence. We're going to load in our reagent cartridge, and then choose from our ready runs. Here it's a drop-down list. Just select the run we want. Again, confirm that this is the correct run configuration because you cannot change it once you start the run. If everything is correct, just start your run and you'll be able to continue. Finally, our third instrument that has local run manager available on instrument is the NextSeq. Let's take a look at what this is on the NextSeq. Here we're going to select experiment. We're going to be sequencing. The NextSeq also has the beat array option. You can switch between manual and local run manager mode here, or enter in your BaseSpace credentials here. Again, in this example, we're not using BaseSpace. Here you can select from your list of ready runs, similar to the MySeq interface. You can also make changes to things like your output folder if you want to change that location to a network drive. change your read lengths in case you need to change that before you start your run. If everything is ready, just click on Next, and then you'll go through the rest of the pre-run checks, loading your consumables, reviewing your run, and starting your run. Now, I've touched on this a couple times, but I want to provide you a very detailed explanation of your second index orientations because this is the most common problem we have when people start using Local Run Manager. So on the iSeq, the NextSeq, and the mini-seq, due to chemistry differences, the second index or I5 index is read in the reverse complement orientation compared to the MiSeq. So when should you actually enter in that reverse complement orientation for your I5 sequence versus the reverse complement orientation, which is how it's actually read on the instrument? If you're running in Local Run Manager mode, you want to use always the forward direction for your I5 index. LRM2 will automatically reverse complement the I5 sequence to the correct orientation when generating its final sample sheet. Now, if you're using IAM to create your sample sheet for Local Run Manager, this means you always select the MiSeq as the instrument type to make sure those sequences are kept in the forward orientation. If you're running in manual mode, in this case, you do need to give the reverse complement of that I5 sequence. This is because sample sheets in manual mode are not validated or processed by Local Run Manager 2. Instead, they're passed directly to the FASTQ generation software without any further processing. So Local Run Manager mode, always the forward orientation. Manual mode, you will need to reverse complement the sequence as necessary yourself. So now we've set up our run, we've performed our analysis. How do we actually see those results? So here we go to the dashboard and see our run that has the analysis completed status. You can click on that run to select it from the dashboard. Once you do that, you'll see a few different tabs. Your run overview gives a general overview of the run performance. So things like clusters passing filter, general clusters, read performance, and the analysis time. This is a broad overview, and it is not a SAV replacement, does not give you all the same metrics as SAV. So if you need to take a detailed look at your run, still use SAV, and that's still available for all of these instruments. The sequencing information tab gives you information such as the instrument that this is running on, the time it was run on, the read lengths, and so on. The samples and results tab is where you're going to actually see the results from your analysis. If you're used to MySeq Reporter, where some of the workflows had interactive graphs or charts you could change the display on, the interface for LRM is a bit more basic in terms of what you can see. Here you're going to mainly just get PDF reports that has the summary results for each sample, similar to downloading an analysis report from BaseSpace. But this is not the end of what you get in terms of your results. You can actually get to more detailed files. The easiest way to get here is from the Samples and Results tab. You have a button to copy the output folder location and then paste it into a path. Here you can then go to your output path, and you'll see a file or a folder called either alignment or alignment imported with a number. This alignment folder contains all of your results, including all of the FASTQ files and anything such as BAM files or VCF files that are also produced by that workflow. This is slightly different from MySeq Reporter. If you're used to MySeq Reporter, you may be a little bit more familiar with the folder structure there, where you had to dig down a few levels. Your FASTQs were located in data intensities, base calls, and then a list of FASTQs. And then the alignment folder was there for any other files. With Local Run Manager, everything is collected all in one folder. Makes them easier to find, but just keep in mind that is a difference. So the first time you run Local Run Manager on a MySeq, if you're looking in the MSR output locations, the files are not going to be there. They're going to be in the alignment folder instead. So that's how you actually get to your data. Let's talk about a few important settings. Through that Tools drop-down menu in the dashboard, you're going to see a few options. Here we'll get to the System settings. When you open that, you'll see a few different tabs. If you have user management turned on, you'll see different security options where you can change things like password expiration, user lockouts, and so on. There is a maintenance tab where you can set up different options for backing up your database. Note that this database backup does not back up your run data. It instead backs up information about the users, runs, and custom settings. So this is a database of what LRM knows about, but not the actual run data. If you need to back those up, we recommend setting an external output location, or you can manually copy the files. The Service Accounts tab sets what account is actually running Local Run Manager. And this is important if you're doing something like writing to a network. Local Run Manager by default runs as the local system account, and this is good for running systems locally on the instrument and writing locally to the instrument. But if you're running to a network, local system is uncredentialed, and most networks do not allow writing to your files. So if you see something like your raw data, your BCL files have been copied to your network, but no FASTQ files, it's usually because the service account running Local Run Manager has not been set to a credentialed account. We do have information about this on our support site. We have a few great support bulletins about setting network outputs and user accounts for different versions. But the general idea is you need to set the Windows account here in the settings that you're going to use a credentialed account on your domain. You can also change the reference genome repository. By default, this location is C Illumina genomes. If you're running this on an off-instrument installation, you may not have room on your C drive for all the genomes to be installed. You can install those on a different drive, set the path here, and Local Run Manager will be able to find them. Custom genomes are supported as a note, and the software guide discusses how to install those to make them visible through Local Run Manager in your drop-down menu. Finally, let's talk a little bit about Audit Trails. So this shows all the activities that have taken place on the system through Local Run Manager. So this will collect information about who is logged into the system, what options they've changed, any runs they've set up, and so on. These audit trails are filterable and exportable. You can export them to an external file. So again, if you're working in a more regulated environment, you need to keep track of who is using your system and what they're using it for. These are the options you would want to set. If you would like to learn any more details about anything we've discussed here, here are some links to the different product pages. We have product pages for each instrument that can run Local Run Manager on board, also the off-instrument version. We have a number of great support bulletins about common questions for Local Run Manager, such as configuring the software to generate FASTQs for index reads, using custom kits, and so on. Then we also have some online training courses from our training department that go over some of the same materials that we discussed here, such as setting up runs and interacting with the software. And with that, we have some time for any questions that you may have, and thank you for your time.